Sorry I haven't been in the last couple of days. This week hasn't gone as planned, but hopefully you read and took notes in the textbook, and you're able to learn some new things and recognize that you already know a good chunk about this section. The section was about experimental design and the scientific method. For us, the experimental design is really important for two reasons. One, we want to be able to do our own experiments, and two, we want to understand the experiments that people have already done so that can help us improve our experiments and learn new things. This unit, the things that we want to learn about are chemical reactions and how we can use chemical reactions to understand other things. In order to do this, we need to understand and explain the mechanisms surrounding individual chemical reactions, and we want to design experiments to get this information. So it becomes a tool for us to learn more. My recommendation for experimental design is that simpler is always better. We've talked about variables in the past, and I know you've learned about independent and dependent and control variables in the past, but it's always worth thinking about them again and reminding yourself what you want to be able to do with your variables. You need to know what you expect to change as you do your experiment and what you want to have control over or try to force to stay the same. Those are the things that we want to have control over. In order to know whether we're successful, we need to know what to measure. For us, the measurements that we've done have been mass, volume, and temperature. The mass and volume usually are how much stuff do we want to start with when we're kind of setting up our experiment. And then we've measured the temperature over time in order to understand, how is energy transferring between the components in our system, what can we get out of the temperature, things like that. Finally, once you kind of set up all your variables and you've kind of started to map them out, you now can come up with a hypothesis. After doing all this work to come up with your variables and what you're going to measure, hopefully you start to understand that a hypothesis is more than just a guess. You're measuring all these things, you're expecting certain things to happen, you're remembering what you know about the mechanisms for the particles that make up the materials that you're working with, and you have an idea of what you expect. This is your hypothesis. People call it an educated guess, but you have to emphasize the idea of educated knowledge, expectation. You know what's going to happen, or you think you know what's going to happen, and that is what builds your hypothesis. It's not always right, but that's okay because you know when it's wrong because the measurements don't line up with your expectations. So in order to be able to put this all together, to check your hypothesis, to make sure you're getting the information that you get, after you've planned your measurements and you've taken your measurements, you need to write down everything that happened when you did the experiment. Any change that happened, any spill you made, any bubbles that formed, any colors that changed. That way you can sit down at the end, analyze all of the data, and come up with an explanation. If your expectation matches your hypothesis, great. If it didn't, it really doesn't matter because now you have something new to explain. Or maybe you have to design another experiment in order to understand it. But that's our goal. We're going to try to break down chemical reactions using experimental design to understand the mechanisms that underlie them and maybe try to explain some other things that we observe in the world. It's hard. You're going to have to learn as we go, but as long as we have this nice foundation of expectation and planning out our measurements and writing down our observations, everything should turn out just fine. Hopefully, I will see you soon and you can ask me questions in person.